28. Find cotangent theta if cosine theta is 1/7 and sine is negative. All right, so let's go ahead and set this guy up. This looks like just extra information to figure out what quadrant we're in. That's usually how it works. And then this guy will kind of inform us how this is going to play out, like what exactly his value is going to be. So unfortunately, cosine and cotangent are not directly related like cosecant and sine. So we're going to have to get a triangle going here. All right. And so if you remember, cotangent is A over O, and cosine is A over H. Okay. So we're going to go ahead and use the cosine values here of cosine from here would be A over H. Okay. So what we'll do is we will figure out what the O has to be, because the O is actually required for cotangent. So let's go ahead and figure out what that is. So we'll set it up for the Pythagorean theorem, but this is a little different because we're going to have sine the 7 squared equals 1 squared plus something else squared. And I guess we'll just call it, I don't want to use O because it looks too much like 0, so let's just call it B. Okay. All right. So let's go ahead and that's 49 equals 1 plus B squared. Subtract 1, 48. So it looks like B squared, we're going to get B equals the square root of 48. All right, square root of 48. 12 goes in there 4 times, so that means 16 must go in there. 4. 16 times what? 16 times what? No, it's not going to be. Is it 3? Yeah, okay, 3. 16 times 3. So what I'm going to do is I'm going to take a pair of 4s that are in there. That is 16 times 3. So we're going to get B equals 4 radical 3. Okay, so 4 radical 3. Now that is the O. Okay, so cotangent now, okay, going back to the beginning of the problem here, equals the A, which was 1 over 4 radical 3. All right, so we're going to go ahead and multiply top and the bottom by radical 3. All right, we get radical 3 over 4 times 3, because radical 3 times radical 3 is 3, and then the 4 is still there, so that's 12. That is our final answer, except it might be negative, so let's just see if it is negative. So let's see. Cosine is positive, so this means we are those two. Okay, cosine is positive. Then it says that sine is negative, and since sine is negative down here. Okay, so it looks like where they both overlap is in Q4. So Q4, we have to ask, is cotangent negative in Q4? And the answer is yes, cotangent is negative because cotangent along with tangent is only positive in 1 and 3. So this guy is actually going to be negative. Okay. All right, so that's how you do those problems. I'm going to go ahead and start working on number 29 in this one. Yeah, we're only at the 4-minute mark. All right, so let's see what we got here. So we got some addition here. So I don't like having a secant either, so I'm going to, he's actually cosine 1 over cosine. So what if I wrote it like this? All right, and you'll see this only by experience. You know, you just have to do lots of these. You got to spend a week or 2 doing these just to kind of see how things play out. Okay. If you were wondering what my boys are screaming about, they play with stuffed animals a lot, and so that they can play violently with them. And so the stuffed animal, one of them was getting ridiculed by the elephant, was getting ridiculed by the ape. Because the elephant got a tattoo of Princess Peach on his butt. And so the elephant started screaming at the ape for making fun of him for this. So when I went in there, the elephant had a sticker of Princess Peach right down his butt. So that's how my kids play. Especially on days that they have martial arts, because they get so jacked up from martial arts that they're just, wow, they're crazy. All right, what am I doing? Well, I'm going to give this cosine x an extra cosine. All right, give him an extra cosine. And so he will be squared now. And then that way they have a common denominator. And then if you look in the numerator, you've got this lovely. Now notice this is one of those problems where you don't know where you're supposed to go. You only know that you're supposed to simplify as much as possible. All right. So sine squared x plus cosine squared x. Okay, that's 1. All right. Actually, we'll save room for 30. So that's 1 because that is one of my identities. That's one of the major ones. That's the one I see the most. I see it on the SAT, ACT, all kinds of college entrance math tests, placement tests. It's always there. So just kind of keep that forever in your mind. All right. And it all comes from the Pythagorean theorem. So 1 over cosine is actually secant. That's good, but this is just slightly better. Okay. All right. So it's kind of interesting that this right here would produce just that. All right, 30. Okay, let's see what we got here. Now the fact that they're both under sine, what I'm going to do is, it's kind of like this where they both have cosine. What I'm going to do is I'm going to split it up like this and go backwards like this. We're going to give that cosecant sign, and we're going to give this sine and just kind of see what happens. All right, because there's nothing else to do. So let's go ahead and do this. That's all I can see. We'll just see where it takes us. Okay. All right. So this is just 1. But let's see what what is cosecant? That actually is 1 over sine. So that actually is just Oh, okay. So if you notice here, what we do have a cosecant squared minus 1. If we have cosecant squared and we subtracted 1, we would get cotangent squared. So cosecant squared theta minus 1, if we moved it over here, we're going to get cotangent. Now watch what happens then. What I'm going to do is, it only kind of, again, experience kind of allows you to see that the sine, if we moved it to the numerator, he will become cosecant, okay? And since there's already a cosecant there, we can actually make that squared. Okay? So it's a little trick. Remember that 1 over cosecant is just sine theta, and then 1 over sine theta is just cosecant theta. Okay? So it's just how the reciprocation works. Okay? So if there's already a cosecant there, and then this guy's can come up, and we can call it cosecant. All right, so anyways, there's 2 of them, and so this allows us to just say that this is cotangent squared beta. Okay, because this is an identity. Okay, you have to look that up. All right, where are we at? 8 minutes. Okay, I'll just put the last 4 in the last one here.